In this video I'm going to explain you about sampling distribution. So what is sampling distribution means? Selecting a particular members in a population, means selecting a random number of things or random number of people in a particular population or a particular things. So that is called sampling. We are picking only some particular and special ones in a group of things. That is called sampling distribution. So here are some four important models I am going to explain you in this video. Four important models of sampling distribution. Those are, the first model is testing of hypothesis. Here the question is, a sample of 64 students have a mean weight. See, a sample of 64 students have a mean weight 70 kgs. Can this be regarded as sample from a population with a mean weight 65 kgs and SD 25 kgs? So here we have to write, we have to know the formula first, that is z is equals to x bar minus mu by sigma by root n. Before that we have to know this one, this table we have to know. Before knowing the formula we have to know this table, that is sample and population. See, we are selecting a particular members in a group of people. So sample means we are selecting them. So see, mean means we are here, sample mean means we are representing mean with x bar. In population we are representing mean as mu. In sample we are representing variance as s square or rho square. We can represent either s square or rho square. And in population variance is denoted by sigma square. And standard deviation is represented in sample as s and population is denoted as sigma. And this is proportion, or proportion is denoted as small p, and in population it is denoted as capital P, and size is denoted with small n, and population is denoted as capital N. See, in this question, a sample of 64 students. Students means here it is denoting number, n number. So which here it is mentioned that sample. So sample of number of students will be measured, will be denoted as small n. So sample size equals to n equals to 64 and have a mean weight 70 kgs. Here it is not mentioned population, so it is under sample. So sample mean x bar. See, mean will be denoted as x bar. X bar equals to 70 kgs, and this can be regarded as a sample from a population with mean. See, population with mean, here it is given. So population mean means we have to denote, population is mentioned and it is saying mean. So population mean means mu. So population mean mu will be it will be denoted by mu is equals to 65 kgs, and SD is given. So SD is because the population word is before the mean and SD, so population mean and population SD. So population SD is denoted by sigma. So sigma 25 kgs. So when we are doing sampling distribution sums, first we have to remember these 2 points, that is null hypothesis and alternative hypothesis. Null hypothesis is denoted by H0 and alternative hypothesis is denoted by H1. So null hypothesis means mean, sample mean equals to population mean. Alternative hypothesis means sample mean does not equals to population mean. Okay. So we have to prove, if we get answer based on this, we have to write the therefore. Okay, based on these two we have to prove either null hypothesis or alternative hypothesis. If we get answer, we will know, then we will know at that time that whether it is null hypothesis or alternative hypothesis. So The next point, immediately you have to write that two-tailed test is to be used, and let level of the significance is be 5%. So here the level of the significance is 5% will be given in the question. Okay, so you have to mention that level of significance be 5%. Here z alpha is equal to 1.96. How this value is came? This won't be given in the question. This value should be known by yourself, because z alpha value will be known by, see, z score. See, the z score formula is x minus mu by alpha. This is not necessary for you now. See, z score of 5% is 1.64. That is, you remember that. So to find z alpha value, first the formula is AL equals to 1 plus CL by 2. CL means confidence level. See, here what is the significance value? 5%. So 100 minus 5 is 95%. For 95% we are finding z alpha value. So 100 minus 95, 95%. 95% in points is 0.95. So the confidence level value is 0.95. So 1 plus 0.95 by 2 equals to 1.95 by 2. So we get answer 0.975. So there is a Z score table. If you Google, you will definitely get the Z score table. Based on that Z score table, you will see the table is like this, where horizontal values and vertical values will be there. You will search for this value in these columns or rows. The table in this format, no? So the table in this format, where here we will have values and here you will have values, and you have to search for this answer under this area. So you'll find 0.975. So you'll check in which row it is there, in which column it is there, in which column or in which row. Based on that row and column, you will plus those two values. See, where you will get 1.9 in the column side and 0.06 on the row top side. Here you will find 0.09, 0.06. So you have to add those values and you will get 1.96. Okay, this is for 5%. So significance value is 5%. So z alpha value of 5% is 1.96. I think now you understand how we got 1.96. First you have to find the A alpha value, that is z alpha value, that is 1 plus confidence level by 2. And first you have to know this z score table. Just Google it, you will find the z score table. So now we'll do the sum, that is test static. The formula is z is equals to x bar mean, sample mean minus population mean by population standard deviation by root over n. Okay, so what is the sample mean here? 70 kgs, so 70, and then population mean is minus 65 by standard deviation is 25 by root over n means 64. So we substitute values in this formula and you got 1.6. See, this 1.6 is less than this z alpha value. So 1.6 is less than 1.96. So H naught is accepted. When the answer is less than the z alpha value, then H naught will be accepted. Okay, so you can write, therefore there is no significant difference between x bar and mu, therefore H naught is accepted. If this is the less value, H naught will be accepted, so H naught is accepted. X bar, there is no difference between x bar and mu. Hence we conclude that sample is drawn from population with mean 65 cases and standard deviation 25 cases. You can write the question, last line of the question. So this is one model. This is the example of, this is the same model I'm not going to explain you because I think one model, one sum is enough. Okay, next model is this one. Second model. A researcher wants to know the intelligence of students in a school. He selected two groups of students. In the first group, there are 150 students having mean IQ of 75 with standard deviation of 15. In the second group, there are 250 students having mean IQ of 70 with ST of 20. Test whether the groups have come from same population. 0.01 and that is LOS, that is level of significance. Okay, I already said that level of significance value here. See, level of significance be 5%. Like here the level of significance is 0.01 means 1%. Okay, see here the question, group of there are 150 students, so n1 equals to 150. And the next is having mean IQ. It's saying mean value. It's not saying population mean. So it is only saying sample mean. No. So x bar equals to 75. And what I said, S1 or rho 1. We can represent standard deviation as S1 or rho 1. So S standard deviation is 15. Standard deviation with the standard deviation is 15. Again, in the second group, there are 250 students. So N2 equals to 250. And having mean of IQ is 70. And with the standard deviation is 20. So level of significance is 0.01 means that is 1%. Null hypothesis, I already mentioned 2 points you have to write in the sum, that is null hypothesis and alternative hypothesis. Null hypothesis is denoted by H0 and alternative hypothesis is denoted by H1. So H0 is equals to x1, that is as I said, x bar equals to mu, x bar equals to mu, and h1 equals to x bar not equals to mu. But here mu value is not there, so x1 bar equals to x2 bar and x1 bar not equals to x2 bar because we don't have mu values. So two-tailed test is to be used. 1%, for 1% the z alpha value is 2.58. You have to remember these z alpha values. Mostly the sums are based on 1% and 5%. So you remember these two z alpha values. For 5% the z alpha value is 1.96. For 1% z alpha value is 2.58. Remember these two because every question they are asking 1% and 5%. For 1% z alpha value is 2.58. For 5% it is 1.96. Okay, z alpha value, I told you how to find z alpha, no? So if you want to try, please try it by seeing zero table in Google. Okay, z score table, not zero table, z score table in the Google, and you will find 1% whether it is correct or not. 2.58, just test it. So 2.58. Now the test static formula is z equals to x1 bar minus x2 bar by root over s1 square by n1 plus s2 square by n2, where s1 not equals to s2, that we know. So we already know the values of n1, n2, x1 bar, x2, s1, s2 values. So we are substituting in it. So we got 2.84 answer, which is greater than the z alpha value. So here H1 is accepted. So there is significant difference. If H not accepted, there is no significant difference. Here H1 is going to accepted. See, hence H1 is accepted. So we conclude that two groups have not come from same population. Okay.